Hello everyone, good afternoon. This is Swarnim Mishra from Team 6 Sense, and we are participating here in Smart India Hackathon, and our project is on computerized adaptive testing. Our problem statement is SIH 1460, which is integration of AI for adaptive learning in MCQ selection in Parak. So, as we can see, this is our team. I'll put, put on them briefly. Then we'll move over to the characteristics of computerized adaptive testing. It is some of its salient features are it provides the user personalized learning. It tailors learning experiences to individual learners according to their skills, levels, and abilities. Next is efficient skill mastery. By adapting questions to a learner proficiency level, they'll keep learning and moving on to the next level. Similar points are reducing text anxiety, data driven insights, and continuous improvements. Many times, when we give normal examinations, we face issues like uh, often we are in the examination, we are stuck in a loop where the question gets difficult, and we are stuck on them. And it increases a certain level of anxiety in the students and make them a little bit of hopeless in examination situations. To counter this, the computerized adaptive testing is a very good format of conducting examinations all over the world. So, as we know that the team Parak under the AICTE has already made their whole question bank of MCQs, and all we need to do here is develop an algorithm which takes a pre-assessment of the users and then caters them to the questions according to their needs. So, moving on, let's learn a little about computerized adaptive testing. As we can see, CAT is an algorithm wherein a test administered by a computer that dynamically adjusts itself to the ability level of each examinee as the test is being administered. So, what does that mean? So, what we are trying to develop here is a web interface which takes a pre assessment of the students who are logging in, and according to the pre assessment, it predicts a level of the students according to their test giving patterns and the time taken on the questions, and then it caters them to a particular set of questions with a difficulty level that matches with their abilities and their knowledge, intelligence, etc. So, CAT can adjust the number and or nature of questions. By this, the students can have a difficulty level according to their uh, capabilities so that they can start off with a healthy test environment. The factors that are considered by CAT is user response to pre-assessment, time spent on each question, level of difficulty, and number of time questions have been asked in the past. CAT works on item response theory and reinforcement learning. That's what we will be working on, and we'll develop an algorithm as well as a web interface regarding to this. Now moving ahead, why computerized adaptive testing? Again, we have the same points. It gives a tailored assessment where the test is tailored according to the abilities and according to the needs of the students, if I might say. Next is its efficiency and precision. Then optimizations. ML machine learning can be incorporated to optimize the selection and generation of the next question based on the test vector responses. Like suppose a person is giving if a person attempts a question, right, and if he gets the question right, then the our algorithm will automatically judge to give the question of the next level with a little more difficulty to the user so that they can keep moving forward, increasing their levels along the way. Now, by any chance, if the user does attempts the question wrongly, if user attempts the question wrongly, then they will reduce the level a little so that the user can attempt that question. So what we are trying to achieve here is that the user attempts as less questions as possible and get as greater grade, as more grade as possible, as higher grade as possible. Now, these type of tests are actually used in current period. It is used in language proficiency tests like TOEFL, etc. It is used in GMAT and various employment assessment tests along the world, around the world. Now, let me tell this slide explains a little bit about computerized adaptive testing. As we can see in the present times, the these type of tests when it takes place, Normally, the difficulty bar is set on 50%. So the person gets a medium level difficulty question and it starts from there. This is what we are trying to change. We are going to incorporate a pre-assessment in our algorithm, no, sorry, pre-assessment in our project, which will then go into our algorithm so that the algorithm will generate a question with a difficulty that it thinks that the user can attempt. So it's doable for the user. Moving forward, we can see how the questions will move forward as the users will attempt the questions correctly. The difficulty will keep rising, and if the user attempts a question wrongly, if the answer is incorrect, then the difficulty level will be slightly reduced so that the probability that the user person gives a response to the question increases. Now, moving forward, web interface is what we are working on. We'll develop the fully functional web interface on which the users can log in, and we are trying to develop a web interface on which there is a high ease of access where user can log in, do their pre-assessments, and then attempt to various tests without any hindrance or lag. Will develop an Android interface as well. It will, and in that Android interface, to ensure the security of all user data, will employ MongoDB and Firebase technology. Then the assessments can be directly taken within the mobile application, so that the person don't have to go access a third-party website or our website or have to open uh, a different browser. Everything will be available on the Android interface itself. The questions will be personalized, and the past records, results, analytics, everything will be available on the Android itself, the application itself. Now, this slide presents the user flow of our project. The candidate will be required to sign in our web interface or the mobile application. There they will go on the home page. There they will have to give the pre-assessment test, and then the results of the pre-assessments will get feed into our adaptive algorithm, which will make a tailored, you can say, uh, assessment of the user, and it will decide the ability, problem solving capabilities of the user, and then it will cater ahead in the actual test according to all these data. Also, we are working so that the existing users will be periodically prompted to retake the pre-assessment so that it keeps updating their skill or knowledge profile, which will result in continuous adaptation and accurate profiling. Now, after the results and feedbacks, it will be assessed by your algorithm so that the next exam will be catered according to his previous performance. Now, the last slide, technology stack. The technologies which we are using are written here. In the app front end, we are using Kotlin for developing Android interface, and then XML. For the back end, we are using Firebase and Retrofit. For the web front end, we are working with React, Next.js, HTML, CSS, and for the back end, we are working with Node.js with Express. Now, the database, all the users' data will be stored somewhere, and that will be managed by MongoDB so that we achieve scalability. And then, machine learning, one of the most important parts, we'll use ML libraries such as TensorFlow, PyTorch, or scikit-learn for developing for developing the adaptive algorithm, item parameter estimation, and predictive modeling. So this was pretty much it for our project. We hope that we get the chance to work ahead on this. So this was our presentation. Thank you so much for giving us your time. Thank you.